Ninth grade. Catlin here with your help on your cool down for lesson 6 here in unit 5 as we do the first night of our homework here. And we're looking at these graphs that match stories, and we're picking out what the quantities are, what's independent, what's dependent. Is what we practice on in class today. So just a couple of quick takeaways if you weren't in class to take some notes. First of all, there's always going to be two quantities in these stories. There's going to be an independent variable, and there's going to be a dependent variable. All right. The independent variable stands alone. All right. The dependent variable depends on what the value of the independent is. The independent variable can be found on the x-axis, and the dependent will be put onto the y-axis. All right. So they kind of have a place that they go in the graph. And whenever we write this function sentence of is a function of, okay, we always set it up with this template. The excuse me, the dependent variable is a function of the independent variable, and you can replace the phrase is a function of with depends on. So if you can say in a problem, for example, distance depends on the time that you are in the car, then you could say that distance is a function of time, which is true for all traveling purposes. All right, so that's kind of the basic notes that we got. Independence on the x, dependence on the y. Dependent is a function of independent, and dependent depends on the independent variable. So all of that's the basic setup for what we need as we go into this problem. Elena starts to walk home from school, but has to turn around and go back because she left something in her locker. On her way back home the second time, she runs into her friend who invites her to the library to do homework with her. She stays at the library and then heads home to do her clothes. Determine which graph fits the story and what the two quantities are. Okay. So let's look at the different stories. Let's start off with something that we can kind of pinpoint in here. She's walk home from school. So she's walking home from school, but she has to turn around and go back because she forgot something. So early on, there's like this change of heart. So that kind of happens in both scenarios. It happens here and it happens here. So as of right now, we could be either one of them. So it could go either way right now. Let's continue the story. Because she left something in her locker. On her way back home the second time, so she's still continuing back home, she runs into her friend who invites her to go to the library and do homework with her. So that would be on the way home the second time. She's like, all right, I'm going to run into somebody here. And then they're going to like, hey, let's go to the library. So they turn around and they walk back to the library and they say they're and do work. Well, that could also be represented here. Like as I come back, do I pause and talk to that friend and then walk back away and then turn around and then go to the library or and then kind of finish my way back to school? What two quantities are mentioned here? So, and then she runs into her friend, invites her to the library. She stays at the library and then heads home to do her chores. So at the very end, she heads home to do her chores. So let's pick a couple of quantities here. Let's say that one of them is definitely going to be time, right? So let's put time down here. Time down here. And let's say that this is school, right? Because that's where she starts the story. Let's see if the first story matches it. So let's go one step at a time. She's on her way home from school. So home in this story would be down here at the bottom because that's where the end of the story at. She's trying to get home, but she gets kind of distracted. So she's on her way home, walking back closer to this place, and then she's like, crap, I forgot my stuff, have to go back to school. She goes back to the school. She's probably rummaging through her locker. And while she's rummaging through her locker to find whatever she was, um, she gets it. And then on her way back home the second time, she's walking home, she stops and she runs into her friend who invites her to the library to do homework. She's like, hey, turn around. Let's go back to the library. Now, the library might not be at the school. It doesn't appear so because it looks like they walk back toward the school and don't always get there. Maybe the library is next to the school, not as close. And then they stop. This right here would represent time working on homework at the library. We'll say homework at the library. So She stays at the library and then heads home to do her chores. So this would be heading home, and then at home I'll get my chores done. So that seems to match everything. This would be time, and then over here we'd have to specify that as distance from home because she's starting at the school at 0 time and then kind of works through the story. Let's see if the other one can match, but maybe instead of starting at home or at school up here, maybe the bottom line down here represents school and she ends up at home up here. Let's see if this makes any sense. So she's at school. She starts walking toward home, right? And then she's like, "Crap, I forgot my stuff. I got to go back to the school, look through my locker, find my stuff. Got it. All right, I'm going to head home again. Heading home, heading home, heading home. I get to this point right here. This is me running into my friend. And my friend's like, "Hey, hold on. Let's go back toward the school where the library is. Not quite there, but let's go back and let's go to the library and do our homework." This would represent homework at the library again. And then he's like, "I got my homework done. I'm going to head all the way home." So this one is the same as the story before, except it's distance from the school, not the distance from home as our dependent variable. So, which graph fits Elena's story? We really could say either one. We could say either one. For this first one, we could say what the two quantities are. They are time and distance from home or school. Time, and we'll just say time and distance. And which quantity is a function of which? Well, since we're just going to lump these into distance, and these are our dependent variables, we would say distance is a function of time. Distance distance Elena is from school or home is a function of time. There we go. So really, either one of these could work. They kind of invert each other. It's just one is a distance from the school, and one is a distance from home. It's just a point of view, a perspective thing, like we saw with the dog example at the beginning of the lesson today. So it kind of took a little while to get through that, but you can answer it with either one works. Time and distance are your quantities, and the distance that they are from school or home is a function of time, is the sentence that we can write about which is a function of which. All right, there you go. Adios, amigos.